Hello students, good morning. So we are going to discuss about the course digital signal processing unit number 4 on the realization of filter. So these are the course objectives, that is DFT, FFT calculation, then FIR filter design, IR filter design, the realization of FIR and IR filter, DSP processor and multi-rate digital signal processing. Now this is the session number 2 for the realization of a filter. So in the previous lecture we studied about how to realize FIR filter. Now we are going to focus for today's session IR filter realization. So for the IR system filter, it can be realized in several structures, that is direct form 1, direct form 2, cascade form and the parallel form realization. So this is a general IR filter structure, direct form 1 and direct form 2. In the session 1 about the FIR filter realization, we studied about the direct form. So here direct form 1, it is a generalized block diagram of the direct form 1 and direct form 2. So when you observe this, the first section, that is the direct form 1, here the P0, P1, P2, it is related to the poles, and this is a denominator minus D1 minus D2, it is related to the denominator. So we know that H of Z equation is how we can write the H of Z equation. So for that we are using the numerator upon the denominator concept, and by using this one we are going to realize in the direct form 1 and direct form 2. So when you observe this, that is the direct form 1 and direct form 2, these are the poles is mentioned here, and these are the denominator minus D1 and minus D2 in the first diagram, it is a mention for the denominator. So when you observe the direct form 1, it is the direct realization. So here we are going to observe that x of n we are taking the input, here we are getting the y of n is the output. So P0, P1, P2, these are the poles, the numerator value. These are the, so not poles, these are the numerator values and these are the denominator values, and directly we are going to realize. So actually we require the different adders, and also we required the different delays. In the direct form 2, we are going to minimize the circuit, means we are going to minimize the delays components, we are going to making half of the delays. Because of that, direct form 2 realization is mostly preferred for design of the IR filter. Now the next part is, this is the general block diagram representation of the equation y of n, a1 y of n minus 1, a2 y of n minus 2 plus b naught x of n. We observe this equation, we found that x of n is a input, y of n is a output. So this is the y of n, x of n. So there are some constant parameters which are attached to the input sequences, that is a b naught, a2 and a1. So what is that? These are the multipliers we are using in the realization. B naught, it is a multiplier directly with the x of n. So here this multiplier b naught is attached with the x of n. Okay. Now the a1 is used for, this is the a1, it is a multiplier, second multiplier, which are connected to the y of n minus 1. So we are going to multiply a1 into y of n minus 1. So z minus 1, it is the delay component which is attached with the output y of n. Because of that, we are taking the from y of n, then it is connected to the delay, it is a y of n minus 1 multiplied with the a of 1. So this, the first part is over after the a1 y of n minus 1. Then we are going to focus for a2 y of n minus 2. So a2 comes here, this is the multiplier, the next multiplier a2, and it is a y of n minus 2. So we require two delays. There are n minus 1, n minus 2. Likewise, two delays are required. Because of that, we are using these two delays. So y of n minus 1 single delay, y of n minus 2 two delays, and here we'll get the output y of n. This is a general block how to represent the any diagram in the realization format. Now the second part, we are going to difference equation, how we can write the difference equation. So suppose for example there is a difference equation, we can write here y of n which is equal to, what we can say that, we are going to say that y of n minus summation k varies from 1 to capital N, okay, a of k, right, y of n minus k, okay, which is equal to summation k equal to 0 to capital M. Okay, then we are going to multiply it with the constant b of k and delay is x of n minus k. So we can say that this parameter related to the x of n and this parameter related to the y of n. When you observe this diagram, we found that, see, in this diagram, what is the input x of n, output is the y of n. How we can realize this difference equation in a direct form 1, or as it is we are going to realize in the direct form 1, x of n, b0, b1, b2, these are the multipliers are attached with the x of n. So directly it is a b0, b1, b2 are in the forward direction. We are using the delays. How many delays are required? It is a k varies from 0 to m. So x of n minus k, k is equal to m. Till we are using this up to the b of m multiplier and n minus m is the delay. So this is the, how many delays are there? N minus m. How many multipliers are there? b0 to b of m. b0 is directly connected, so x of n minus 0, so it is a x of n. Because of that, we need not have to use the delay in the first place. b0 is directly attached. There is a summation symbol. Because of that, with this summation, we are using the adder at every place. So b0 plus x of n minus 1 into b1 plus x of n minus 2 into b2 plus and so on x of n minus m into b of n. So likewise, this is the related to the input x of n that we are going to use here in this the right side of the equation. When you are going to focus for the left side of the equation, we found that y of n is the output. If you are taking y of n equal to c, which is equal to, we are using this a of k, y of n minus k. So a of k means what? A of k related, it is started from k varies from 1 to capital N. So it is not a0 value is present in the equation. So a1, a2, a3 up to the last point is a of n. Those are the multipliers are required. We are using y of n equal to minus, or if you are using this one equal to minus, it becomes plus here at this side, and we are taking the out a1, a2, a3. So what is the, it is in the reverse direction. Arrows are mentioned in the reverse direction because we are taking the samples from y of n. Because of that, y of n, here there is a no first value, second value is y of n minus 1 into a1. That is k equal to 1 in the a of k, y of n minus k. In this equation, k equal to 1. So a of 1, y of n minus 1. A of 2, y of n minus 2. And the last element is a of n, y of n minus m. Likewise, we are going to realize the difference equations in the straight way. In this way, we are going to realize, this is called as a direct form 1 realization. So we are going to focus the next part of our this concept session, that is a direct form 2. So no need to store the sum data twice in previous system. That is the second advantage of this one, means need not have to store. So we can collapse the delay elements into one chain. It means that instead of the bunch of delays we are using at the two sides, we are going to reduce it and make it single. That is a in the common delay we are using. This is called as a direct form 2 or the canonical form. Theoretically, the difference between direct form 1 and 2, which is this is the theoretically, there is no difference between direct form 1 and 2. But to minimize the hardware, we are using the direct form 2 generally. So if you want to realize the direct cascade realization and the parallel realization, this is the next part of our this session. So for that we are selecting the direct form 2 realization. Okay, now the next part is, this is the direct form 2 realization. In the previous equation we studied about xn, yn. Here is the mediator, we are middle component we are using as a wn. So y of n, b0, b1, b2, bn is attached here. It means that left side multiplier are transferred to the right side multiplier transferred to the left side. Only the sign of this what we can say that a1 to a of n, it is a changes, that is a minus a1, minus an, minus an, up to that. So these are the, what we can say, that these multiplier signs are changed, and we are using the direct form 2 structure likewise. We'll see example here. Just observe this example. This is the realization of a filter by using a direct form 1. So y of n minus 3 upon 4 y of n minus 1 plus 1 upon 8 y of n minus 2, which is equal to x of n plus 1 upon 3 x of n minus 1. This is the given difference equation we are going to realize by using a direct form 1. How? So for that, first of all, we'll have to make the equation in terms of yz upon hz. So we are going to apply the inverse z transform, and here also we are taking some dummy component, so that is called as a wz. So in the direct form 1, it is just a structure in the direct way. Because of that, some middle term we are going to select, that is a wz upon xz. This is the h1z we are calling as a h1z, and wz upon yz upon wz. It means that h2z having the input wz, right, and h1z having the input x of z, h2z having the output yz, h1z having the output wz, and then we are going to realize. Now, first of all, you make the difference equation. From the difference equation, find out h of z. So after applying this in the previous this one, we are going to study about that. These are the subsystems we are using, and from the difference equation we are going to find out the yz upon xz. So this is h1z, numerator value we are going to assign as a h1z. This is the numerator value. Denominator, 1 upon denominator, it is a separate h2z. So these are the two h1z and h2z we are going to use here. Okay, then we are going to realize. So how to realize this one? This is the part of h1z. It is mentioned here. This is the h1z, and this is the whole part is h2z. Observe this, in the h1z only the numerator part is there. When you observe this equation, it is a very simple 1 plus 1 upon 3z minus 1, that you want to realize. So one only single delay is there, single multiplier, 1 upon 3 is multiplier, and x of n minus 1 is the output, x of n minus 1. So x of n minus 1 and 1 upon 3 into x of n minus 1, or 1 upon 3 into z raised to minus 1 into x of z, right? By this way also we can write. So this is about the first thing. Second thing is that this we are calling as a h1z. H2z is directly here we are using Wn is the input, Yn is the output. So 3 by 4, when you observe the previous equation, 1 upon 1 minus 3 by 4 z minus 1 plus 1 upon 8 z minus 2. So here minus 3 by 4 and plus 1 upon 8, these are two multipliers, and delays are 2 required. There is a no first what we can say, that here in this arrow, that is the first arrow, there is a no delay. Directly we are using here y of n minus 1 or y of n minus 1, or another way z raised to minus 1 into yz, y of n minus 2 z raised to minus 2 into yz. So we are using these components multiplied with the constant value which are mentioned in the equation, 3 by 4 and minus 1 upon 8. So plus 3 by 4 minus 3 by 4, it becomes plus 3 by 4, and plus 1 upon 8, it becomes minus 1 upon 8. So that major change is made here in the realization, right? This is about the direct form 1 realization. Now we are going to focus for just difference equation for the direct form 1 realization is given. This is the one difference equation is given, x of n minus 1, y of n minus 1, y of n minus 2 likewise, and we are going to realize by direct form 1 and direct form 2. The whole equation is mentioned here. When you observe this one, xn 0.5, these are two multipliers are required, but x of n minus 1 term is not there. So we are using the single 0.5 multiplied with the x of n in the first element here. Now here minus 0.5 is used here in this equation multiplied with the x of n minus 2. When you observe this, minus 1 upon 3 x of n minus y of n minus 1 and minus 0.36 y of n minus 2. Okay, So in the direct form 1, and this is the realization in the direct form 2, but only thing is that we are using the delays, common delay, instead of using a separate delay. For x of n minus 2 also we require 2 delays, y of n minus 2 we also require 2 delays. So likewise we are going to realize by direct form 1 and direct form 2 realization. Again I repeat, in the direct form 2 realization we are going to minimize the component for IR system design, and direct form 1 it is a very straightforward. Only thing is that when you are going to realize in the direct form 1, you just make the segment x of n, wn and y of n. Then numerator value and the denominator. If there are two different sequences are there, numerator and denominator is there. Numerator we are calling as a xn and wn. In between that, then we can realize the filter, and wn and y of n, in between that 1 upon denominator we are calling as h2z. So h1z, h2z, one dummy component wn we are going to take and realize direct form 1. In direct form 2, to minimize the hardware, instead of using delays at two sides h1z as well as h2z, we can use the common h1z, common delays for h1z and h2z, and we are going to minimize the hardware. So likewise direct form 1 and direct form 2 IR filter realization is completed here. Thank you very much.